Hello, welcome to RCC's Math Tape 091, Solving Systems of Linear Equations by Graphing. If you have forgotten how to graph a linear equation, you can view RCC's Math Tape 082 for a refresher on that topic. It's essential that we have accurate graphs to be able to solve systems of equations by graphing, and so throughout this lesson you need to use graph paper. If you do not have graph paper, you can use stamps of graphs that are found in the math lab. As always, as you go through the material, take careful notes and mark in your notes any places that you don't understand so you'll know what questions to ask when you go to the lab. The lab instructors and tutors will be glad to help you with questions in the material or in the exercises I give you that give you trouble. Now let's begin. On this tape we have two objectives. Objective 1, determine whether a given ordered pair is a solution of a 2x2 system of linear equations. Determine whether a given ordered pair is a solution of a 2x2 system of linear equations. This is what we'll do when we check the answers that we find after we do Objective 2, which is solve 2x2 systems of linear equations by graphing. Solve 2x2 systems of linear equations by graphing. Our goal in this tape is to solve 2x2 systems by graphing. Once we find what we think is a solution, we can determine whether the ordered pair is a solution by Objective 1's effect. Now, what do we mean by 2x2 system? A 2x2 system. A 2x2 system consists of two equations in two variables. A 2x2 system consists of two equations in two variables. Two equations, two variables. 2x2 system. An example of this is 2x plus 5y equals negative 11. 3x minus y equals 9. Notice that we have two equations. 2x plus 5y equals negative 11 and 3x minus y equals 9. Two equations. We have two variables. The variables are x and y. In this system, the x and y show up in the first equation. The x and y also show up in the second equation. This is not always the case. Sometimes only one letter might show up in one equation or the other. But the crucial thing is the system has two equations with two variables in there somewhere. What about a solution? What is a solution? Well, a solution of a 2x2 system is an ordered pair that satisfies both equations of the system. A solution of a 2x2 system is an ordered pair that satisfies both equations of the system. If the solution only satisfies one equation but not both, then it is not a solution of the 2x2 system. It might be a solution of one of the equations. But for it to be a solution of the whole system, the ordered pair, notice that the solution will be an ordered pair, since we have two variables, and that ordered pair must satisfy both equations. remember that it's not enough to satisfy just one of them. It must satisfy both equations of the system. Well, how do we determine whether an ordered pair is a solution of a system? Let's look at an example. We're going to take the system you just wrote down and answer the question, is 2, -3 a solution of that system? Is 2, -3 a solution of 2x plus 5y equals -11, 3x minus y equals 9? Well, let's find out. In order for this to be a solution of the system, this ordered pair must satisfy both of the equations. So let's try them one by one, which is the only way we can. We'll try the first equation, 2x plus 5y equals -11. And we'll do our usual check format. Remember the T shape that we use for checking equations? And in our check format, we have on the left 2 times the x number plus 5 times the y number. On the right, we have just -11. We're checking 2, -3. Remember that in the ordered pair, the first coordinate, the abscissa, is the x coordinate. The second coordinate, the ordinate, is the y coordinate. So this means 2 stands for x and -3 stands for y. So in place of x, we'll fill in 2. In place of y, we'll fill in -3. On the left, multiply. 2 times 2 is 4. 5 times 3 is -15. On the right, there's no work to be done, so we simply copy. And then 4 plus -15 is -11, and so we get -11 on both sides of this check. That means, yes, the ordered pair satisfies the first equation. Does that mean that the ordered pair is a solution of the system? No. All that means is we're halfway there. We must still check the ordered pair in the second equation, so let's do that one now. We'll copy down 3x subtract y equals 9. Set up our T format for checking. And we're going to fill in the x number and the y number for x and for y. So on the left we have 3 times the x number, subtract the y number. On the right we have just 9. The x number in our check is 2, the y number is -3, and so we have 3 times 2, which is 6. 6 subtract -3 is 6 plus 3. On the right we have 9. This gives us 9 on both of them. This checks. Is that enough to tell us that the 2, -3 is a solution of our system? Yes, it is, because the ordered pair does satisfy both equations, and so we can go back to the question, is this a solution? And answer yes. Yes, this ordered pair is a solution of 2x plus 5y equals -11 and 3x minus y equals 9. Let's try another. Is -5, 1 a solution of x minus 3y equals -8, 2x plus y equals 12. X minus 3y equals -8, 2x plus y equals 12. We set up our check with the x minus 3y equals -8. And this means that we have the x number, subtract 3 times the y number, and on the right, -8. The x number we're using is -5. The y number we're using is 1. So on the left we have -5, subtract 3 times 1. On the right we have -8. -5 subtract 3 on the left, -8 on the right, and -5 subtract 3 is -8, so Yes, this works out. Great, we're halfway there.